Chapter 2.5 Concepts to Theorems. Natural Sciences. It is useful to recall the difference between arithmetic and algebra. In the first case, we try to solve every question that is posed to us, add two sums, three sum, and so on. Or exercise 1, 2, 3 is subtraction, or to go further to multiplication and division. Each exercise is solved individually. In algebra, we have a formula or a method of solving a problem. If a plus b is multiplied by a plus b, we start with a in the first set and get the following result. A into a plus a into b is equal to a square plus ab. Then we start with b of the first set and multiply with each other. We get b into a plus b into b, or ba plus b square. Now we add both the results. We get a square plus 2ab plus b square. So we have a formula: a plus b whole square is equal to a square plus 2ab plus b square. And likewise we can go to a plus b whole cube to get further results, but let us remain with the first sum. A plus b whole square is equal to a square plus 2ab plus b square. This formula will be valid for all the values of a and b. It can be that a is equal to 2 and b is equal to 3, and our result will be 2 square plus 2 into 2 to 3 plus 3 square is equal to 4 plus 12 plus 9 is equal to 25. We can go on increasing the value of a or b and get the desired result. Here we need not calculate each exercise, but use this formula to answer various values of a or b, be they 4 or and 5 or 7 and 9 and so on. The algebraic exercise applies to many cases. This is something like discovering a principle or a common method for doing each calculation individually. The discovery of a method common to several cases or a type is a step forward in involving a formula, something like a theorem. Let us now move to a set of theorems. Remember our school days learning geometry. We learn about a point, a line, an angle, a triangle. Then say a triangle has three angles and their sum is 180 degree. If one angle is of 90 degree, the other two have to share the remaining 90 degree in any combination, say 60 degree and 30 degree, or 45 degree and 45 degree. In the later case, two sides will be equal in length. If all the three angles are of 60 degree each side of the triangle will also be equal in length. Here a relationship is position between the degree of the angle and the length or size of a side. We can go on further to read about triangles and quadrilaterals and reach the connected 28 theorems. The interconnection of theorems then leads to theory in general, or an all-bracing theory. Reflection and action. Read section 2.5 and give your explanation, interpretations and commentary. In the example last given, word like a point, a line or a straight line and an angle are concepts. Their interconnections a theorem, the interrelations among them a theory. In natural sciences, say in physics and chemistry, we come across words, concepts, their interrelations, and then interconnections among concepts expressed in quantities that lead to theory or better laws. We take an example of an apple. It fell down from the tree, a normal occurrence, but Newton asked the question, why did the apple fall to the ground? He propounded the theory of gravity. Not apple alone, but all objects fall towards the ground. If the earth is round, then why do people on the other side of the earth do not fall away? This doubt was expressed by our villagers. Why do the Americans on the other side of the globe do not fall away? Newton had an answer. All things fall towards the center of the earth. This explained all faults. Thus, the theory of gravity came into being. The explanation came with Newton. Though apples or other objects had been falling that way ever since the creation of the earth, here we can sum up the process of theory formation. Theory is an explanation of recurring event to and is a valid explanation universally in space and time. The condition under which the theoretical statement would hold true need to be spelled out. The theory can be modified if subsequent experiments create new situations that have to be considered afresh. The theory is a revisable proposition. Examples are the theory of the atom being indivisible part of matter had to be revised after the splitting of the atom. The case of discovery of elements beyond 92 has earlier been stated. The theory of gravity was given a new look when a non-matter or a force like light was found to be subject to gravity by Einstein. Science is impersonal in the sense that the laws and the theories do not depend on their truth value on the status of a person, be he a king, a prime minister, priest, or even the scholar himself or herself. When an inquiry is conducted or a problem solved on the basis of existing knowledge about concepts and theory and illustrated as a case of a more general application, it is called a deductive approach. We move from the theory to facts. When we move from facts and arrive at an explanation, that process is called induction. The interplay between inductive and deductive process constitutes the method of science or sciencing. Here conclusions are only provisional and are under constant testing and revision. As a process, body of science consists of revisable positions. Some authors are of the opinion that the science grows double, say every 10 years, and after 50 years quite a few conclusions or theoretical statements need modification. The next chapter is 2.6, the Towards Social Science, Durkheim, Weber and beyond.